Hi, I am Samigdha and I will be solving question number 2 of homework 2. So, what have you been given in the question? So, there is a noisy channel through which the signal x1 passes and produces an output of x2. Similarly, for kth, after kth channel. So what we have been given is probability of x1 is equals to 0 is 0.2 and probability of x1 is equals to 1 is 0.8. And for all k, the following probabilities have been given. So the part A of the function refers to we have to find the probability of x2 equals to 1. So how can we do it? So we can do it by probability of x2 equals to 0, comma, probability of x2 equals to 1 can be written as 0.2, 0.8 into the following probabilities 0.4, 0.3, 0.7 is equals to 0.36, 0.64. So how we are multiplying these two values? We are just taking the respective probabilities of probability of x1 equals to 0.2 and x1 equals to 1 is 0.8 and 0.6 level probability of x2 equals to 0 given probability of x1 equals to 0. So and similarly and so on. So we can write as probability of x2 equals to 1 is 0.64. So applying similar approach, we can write probability of x3 is equals to 0 and probability of x3 equals to 1. It can be derived from the similar notion that probability of x2, then it we just multiplying it. So what we can write is probability of x2 equals to 0 and probability of x2 equals to 1 into 0 0.6, 0 0.4, 0 0.3 and 0 0.7, which can be written as 0 0.2, 0 0.8 and this is 0 0.6, 0 0.4, 0 0.3, 0 0.7 square, which can be written as 0 0.408, 0 0.592. So probability of x3 is equals to 1. It is 0 0.592. So probability of x3 equals to 1 is 0 0.592. Now C part is probability of x1 equals to 0 given x3 is equals to 1. It can be written as probability of x3 equals to 1, x1 equals to 0 and probability of x1 equals to 0 over probability of x3 equals to 1. So now probability of x3 equals to 1 given x1 equals to 0, it is probability of x2 equals to 0 given x1 equals to 0, probability of x3 equals to 1 given x2 equals to 0, plus probability of x2 equals to 1 given x1 equals to 0, probability of x3 equals to 1 given x2 equals to 1. Okay, so this can be written as 0.6 into 0.4 plus 0.4 into 0.7, it is equals to 0.52. So therefore probability of x1 equals to 0 given x3 equals to 1 is equals to what? this is 0.52. Probability of x1 equals to 0 is 0.2, and probability of x3 equals to 1 is 0.592. Now this is 0.1757. Okay, so the probability of x1 equals to 0 given x3 equals to 1 is 0.1757. Now the D part, we have to find limit n approaching infinity probability of xn equals to 0. So we can write as probability of xn equals to 0 comma probability of xn equals to 1 can be written as 0.2, 0.8, and this is 0.6, 0.4, 0.3, 0.7 to the power n minus 1. So we have the nth power only for this term. So let a is equals to 0.6, 0.4 and 0.3 and 0.7 to the power of n minus 1, which can be written as a 1 minus a, b 1 minus b to the power n minus 1 to the power n. And why we are doing it? We are doing it to make our calculations easier. So if we apply the limit n approaching infinity a, which can be written as limit n approaching infinity, this is a, this is a, b, this is 1 minus a, 1 minus b to the power n minus 1. So after applying all the necessary calculations and raising it to the power and applying the limit and approaching infinity, it becomes 0.3 by 0.7, 0.4 by 0.7, this is 0.3 by 0.7, this is 0.4, 0.7. Okay, so limit n approaching infinity probability xn equals to 0, xn equals to 1, this is 0.2, 0.8 into a, which can be written as 0.4286 and 0.5714. So therefore limit n approaching infinity probability of xn equals to 0, it is 0.4286.